Gordon is our master student working on this project. He's also a full-time employee at Pacific Northwest National Laboratory. We're happy to have as much of his time as he'll give us. And Gordon, I'm going to stop sharing here and turn this over to you.
All right, I'll take over. All right. So my portion of this presentation is pretty much focused on interpreting the results that we got from our machine learning algorithms and all the data we kind of accumulated through the process. There is a lot of data there, and so it took a lot of filtering down just to get to what we really wanted. But I'll tell you a little bit about myself. Professor Miller already talked about it, but I have a bachelor's of science of computer science from Washington State Tri-Cities. I'm also currently a software engineer at PNL, so that's where I spend most of my time. I work full time there, and then I'm only part-time here at WSU Tri-Cities, but this is my first year, second semester, so I'm still kind of learning the ropes of graduate school, but it's been very interesting so far. This research has been very fun to get into and explore all the results we're having, and continue on where the previous graduate student left off. So yeah, a couple acronyms. You guys probably know most of these, but just in case you don't, CWE, well, machine learning is ML, pretty obvious. CWE and CVE. So CWE is common weakness enumeration, and CVE is common vulnerabilities and exposures. And a cluster is just a grouping of data points that we've collected from our machine learning algorithms. And there's some similarity in there that the data or that the algorithm decided they should be grouped together. So I'm going to let Tim take I'm going to let Tim take the time to show you guys all the user interface we have. So I'm just going to summarize it here real quick, but our output will give you basically the details of the CVE you already provided. So it'll give you a description, the ID and other stuff like that. That's important for your analysis. And then the cluster that are also, or a cluster of CVEs that are also associated with it. The top two predictions on CWEs, and yeah, it'll show you the order of which one's 1 and 2. And then as well as a listing below that, that'll show you all the other ones that are not in the top 2, but we do limit it to only everything above 5% relativity. So we try to weed out some of the noise in there because, as you can expect, sometimes there'll be false positives or false negatives. It's very, very low percentages, and they still show up in our listing, but we try to eliminate those for usefulness. But we do have that data in case we do ever want to come back to it. That is something we do have. So here is an example of a cluster 107. This is one example I've been playing with recently. Cluster 107 is pretty interesting. You can see on the very right there, a list of all the CWE IDs that we believe are related to it. And you can see percentages, 25% being the top percent and 17% being the second. And you can see in our prediction, that's how they come out as well. And you can see individual counts of how many instances showed up there. And then the total count at the end that kind of lets you do your math for percentages. We had a little interesting math hiccup there with the total. And so it is just an approximation right now. It's just a calculation off of the other values in there. One interesting thing that Professor Miller alluded to was the way that CWEs actually interact with each other in a hierarchy. And this is one interesting example, which is CWE 70, cluster 107, CWE 707 is the root of it. But the top two that you saw in that last picture were 74 and 89. And what we see here is that with 704, it's the root of both of the two predictions, which is interesting because that means that, of course, they're related, as you see here. And so with relationships, you can kind of see that there are similarities in the actual contents of the CWE. And it's pretty obvious because they're, this one's a grandchild, or 89 is a grandchild of 74, and you'd expect that because 74 is supposed to be the higher level, a more general CWE. And so there's expected to be relationships there. But in our case, what we found was 74 was the primary CWE and 89 was the secondary. In this case, we're still trying to understand why it picks 74 over 89. That's kind of an odd behavior we haven't quite figured out yet. But for most general like grouping, what we've been doing is we go by the lowest level, like he said, the leaf CWE first, because they have more detail and more granularity in that sense. And it doesn't always work, but for most cases, you can go with that and be general and assuming that most of both the primary and secondary are actually part of the child, the lower leaf node. Cluster 70 is another interesting example, but this one is interesting in a different way. You can see the first prediction is 119 and the second is 20. And you can see the listing just like on the other picture. 32% being the top and second. So they are very close in competition for that first place spot. And in the chart, you can see that as well, the pie chart. But the difference with this one with cluster 70 is that you see there's two different roots instead of one. And so 20 actually lands in a totally different tree than 119 does. And that is another thing we haven't quite understood, but what we do find is that there are often similarities in wording, or they're not quite related, but they are very similar CWEs. And so that is another good sign that it is actually working. And we're getting CWEs from different trees that have very similar linkages there in wording and up description and all that stuff. So going forward, we have a couple ideas of where we're going to go with this project. One of the current limitations we have is with search, and we've been working on this part, but at the current time, we can search by CVEs that are already in the NVD NIST databases, but we can search by the ID and get the data out of that, which is great. We can take all the current CVEs and place them in the clusters, but what we would like to do in the future is add an enhanced search where you can actually put a new vulnerability description directly into a search and have it run through all the processes of language processing, B2W BERT, clustering, k-means, all that, and actually place your vulnerability with words in our clusters and give you some related CVEs and CWEs. That's the goal going forward. We're still working on that. We've had a couple problems with the batch processing in B2W BERT that we haven't been able to overcome yet, but we have some ideas and we're working forward on that one. I think I covered everything. The other thing is on our website, we have, or on the site we use, we have a good display of all the data we currently have, but a lot of like analysis and stuff like that, we're doing manually with Excel, Python scripts, all sorts of just manual data. And the scripts do help speed things up, but a goal of mine for going forward is I would like to start integrating some of those analysis scripts into the website itself so that when it does all the processing and we get that data, we can start adding additional details that can help you guys as end users to get more insightful analysis on it and make better decisions based on that information. And so that's my goal for next summer. And of course, on top of this, we are also tweaking algorithms as we go and getting better every time. So, yeah. All right. That is pretty much it for me. Does anyone have any questions about analysis or anything else?
Yeah, so I think Dr. Miller mentioned while he was talking that some of these CWEs are very common, some are very rare. I'm just curious, what are some of the common ones? Like you mentioned 707, and I looked that up and it looks like maybe a SQL injection type of thing or something. So just, yeah, what are some of the vulnerabilities or these weaknesses that are the most common?
So I have to look at the tree structure. But yeah, 707 is like at the very top. So we call it a root node because it doesn't have anything that it's a child of. That's the general assumption there. And so 707 is at the top of the tree. And so there are several different CMEs underneath it. And it is very general. And I think you were right. I think it is SQL injection. I believe I read that. But there are several of those. But let me go off script there, I guess, and see if I can find that for you. I believe there are maybe 12 that I found that are kind of like root ones where they are root CWEs where they don't have parents above it. And so I think I have that list.
I'm just curious, like what these most common.
So I have a list of numbers, but let me see. 707. Yeah.
707 was improper utilization. So I would move forward just because it's not really anything on that pretty much.
Yeah. So, oh yeah, I just got pulled up, but yeah. So that you said will apply to most things on the internet. So it gets to at that level, it gets really high level where it's so vague you can't really associate it with one specific thing. But in general, it's talking about network technologies like that.
So one of like, it would have children or grandchildren that specifically talk about like SQL, JavaScript or something.
Yes, and yeah, and you can dive into the. Let me see if I have a JSON listing here that's kind of the main ones we were looking at as root nodes in our data set. And so there are several. There's 10 of them basically right now that I'm tracking that are like root nodes where they're at the top level. But if I expand out these, each one kind of dives deeper and deeper and deeper into all the children that it has. And one of the odd behaviors we've been having is we really expect there to be about 3 levels, but in some cases we're finding like 4, as you can see with those ones there. But yeah, these ones we classify as leaf nodes, and these go all the way down to the bottom CW9. See if I can find that. So, and even this one is a little vague, it looks like, but it's a child of incorrect privilege assignment. And so you can work your way, if you start at the leaf nodes, you can also work your way back up to the root. But I encourage you to go to the CWE website and you can search for the search engine here. You kind of look through the different ones and find more specifically what you're looking for. Any other questions? If not, I think I'll. Oh.
So the way you have it ranked, essentially each tree is noted. Once it decides, like, does it go for multiple trees? Like it can be, I'm not sure if this one or this one, or does it generally decide the tree? I'm just not sure.
From what I found, usually they are pretty specific. Like they usually have one parent in general, but I have found a weird one where it does have more than one parent. So occasionally, I think it can be related to more than one spot, which is it's a weird case, but it ends up showing up twice in some ways, which is does make it difficult to map it, but yeah, they can do that.
Dr. Miller mentioned that the CWEs are assigned by experts that who what those experts, like people at PNL or government organizations.
That is a good question. I would have to, yeah, Go ahead.
MITRE has a collection of companies called, I think, CSP. And these are companies that are authorized to create and actually add the new CWE and CVE entries. So it's all managed by MITRE, which is also managed by NASD.